Okay, so we continue working through this balanced equation. The question on the worksheet was how many grams of nickel 2 hydroxide will we make? And in order to determine that, we have to determine the limiting reactant. So we discussed this in class. When we look at the reaction, it takes 2 potassium hydroxides to react with 1 nickel 2 sulfate. So it takes twice as many KOHs as it does the nickel 2 sulfate. Based on the molarity and volumes given in the problem, we know we're starting with 0.02 moles of potassium hydroxide and 0.03 moles of nickel 2 sulfate. So you could actually look at those two numbers of what you have and reason out that you're going to run out of the potassium hydroxide. Not because it's the lesser number, but because it takes twice as many of them. So in other words, if we have, this is what we have, 0.03 moles of nickel 2 sulfate, well, based on the stoichiometry of 1 to 2, since that's what we have, then we're going to need 0.06 moles of KOH, which we don't have. We only have 0.02. See, and that tells us that KOH is the limiting reactant. Another way to look at that is say, okay, well, we have this much KOH, and according to the balanced equation, we need half as much nickel 2 sulfate. So that means if we have 0.02, then we, forgot how to spell, then we need 0.01 of this. Well, we've got plenty of that. See, we're not going to run out of nickel 2 sulfate. If you can't look at it and reason out limiting reactant, that's okay. Because the other way, the way I taught you guys in chapter 3 to solve this, is to start, we're going to work one number. We're first going to work with just the KOH. Okay, so if we have 0.0200 moles of KOH, we're going to convert from moles of A to moles of B. If you don't like that flow chart, that's okay. Hopefully you still know what to do without using the flow chart. The way we convert from moles of A to moles of B is we use our balanced equation. It says I'll make 1 mole of nickel 2 hydroxide for every 2 moles of KOH. And again, how did I know to put nickel 2 hydroxide on the top? Well, that's what the question asked for. Okay, and my next step is to convert to grams of nickel 2 hydroxide. And that's going to be using the molar mass of NiOH2, which I did not calculate beforehand. Okay, the molar mass is 92.71 grams. So the answer is that will make 0.927 grams of nickel 2 hydroxide. Okay. Now the further calculation, we need to do the same thing, but we need to work with this nickel 2 sulfate number. Okay, so I'm going to take that number, 0.0300 moles of NiSO4. The balanced equation says I'll make 1 mole of NiOH2 for every 1 mole of NiSO4. And then I already know from my previous calculation that the molar mass of NiOH2 is 92.71 grams. So this says I'll make 2.78 grams of nickel 2 hydroxide. Now, nickel 2 hydroxide, in both cases, this is the product, right? It's the precipitate, the solid. Which of these answers is right? The 0.927 or the 0.278? Remember, the smaller product is the right answer, and it points you back to the limiting reactant. Okay, so that's multiple ways to do limiting reactant. You can pick whichever way works best for you.